好。
Thank you very much. 1 year has passed very quickly. This is the first time we hold our technology symposium this year. We really appreciate your coming. Over the past 17 years, we have always been relying on your support to make it this far. Today, I see a lot of our customers, our supply chain partners, our investors, and the media here with us today. The purpose of this event is to share with everyone our progress with technology. We have been doing Wi-Fi for over 17 years, and we continue to improve our technology and capability. We keep moving for past 17 years. It's a very challenging industry, but it's very fulfilling. For over the 17 years, we hope to continue to improve ourselves on this path and move forward and forward continuously. Today, I wish to take this advantage to share with everyone our progress with our products and technology. And in the end, I want to thank everyone again for your coming and your support, and wish you the best with everything you do. Thank you.
We are thank you, Eugene, to teach us new technology about Wi-Fi 7. We are moving to the second section. Hi everyone, I am the SC1, represented by RichWave. We are update about Wi-Fi new status and a new update and Wi-Fi and 5G. To the time involving, what is would be widespan, not just for the terrestrial. For the past, most of them using a wire like a cable or DSL together communicating within city and communities. However, in the future, in the low orbit communication, and also the following 5G, there will be much more wideband, not just for city and city, but also nation, and also not just for terrestrial, but also in the airs. So overall, 5G and with new communication and also new protocols. Overall, we can bring up the whole network communication throughput, and with 5G with the multiple edge centers have a very low latency. So this whole network can be connected together, bring up the whole throughput overall, and then Wi-Fi will be the key to the last mile. For the RichWave, we are established from Wi-Fi and also migrate to the future in 5G. For 5G and Wi-Fi will be the complementary technology. The Wi-Fi in the in the building between can be used on a 5G. Within the houses can be used attached within multi-unit in the houses. So these all need the good protocols and good communication products to reach this target. So to Wi-Fi, this very low latency and high breadth, and that will be a critical technology to the last mile in the future. As Eugene said earlier, Wi-Fi can even reach up to 46 gigahertz bit per second in the future. Leverage with 5 gigahertz, they can wider range. So, what RichWave can provide 5G and Wi-Fi applications? So as RichWave, we provide start from Wi-Fi 4 up to even a Wi-Fi 6E. We provide a variety combination of the RF components, including Wi-Fi power module, standalone PAs, standalone LNA switches. And also for the LTE side, we start from 4G and migrate to the 5G. Combined together with Wi-Fi and 5G, RichWave will be provide full portfolios I've need for 5G and Wi-Fi. So we hope with our RichWave RF component can be bring up everyone's products be good communication. So what our value to of RichWave to wireless products by RichWave? This picture just shows for the upcoming Wi-Fi 7. The top picture is the 1,000 crowns is using as the Wi-Fi 6. In the future, there will be much lower. There will be much narrow in the constellation chart. Will be 4,000 kwon. This shows that in this high density of communication, you can not have signal lost. And also one of the key features is the bandwidth up to 320 megahertz bandwidth. The higher bandwidth, the higher throughput can be achieved. However, this bandwidth, high bandwidth, but need to have the very high accuracy cancellation as well. So we've reached this high density and high throughput and high accuracy. That's how RichWave RF component helps us. With RichWave, value is to get the signal more accuracy even with this high density cancellation. That's what RichWave does for RF component. Through our RF component, we could help the product to get larger range, communication range with very good quality and accuracy signal when using our RF components. And what is our RichWave's competitive of the products? How we achievable? For RichWave, we are the fabric company, so we could use any technology we want without limitations. For instance, we power amplifier, we can use gallium oxide or silicon germanium process. For element switch, we can use CMOS or SOI technology, and same as the filters. So we all can combine whatever we can achieve and then provide a very good cost-effective solutions. And to the not just the process but also suppliers, we use the multiple resources to ensure our product can be fast on time, and they all be in-house design. So what's our value for the Wi-Fi products? The first is that we can support our RF component can support the very stable linear powers. So since, as mentioned earlier, Wi-Fi is the major technology for last mile in-house. So there is a much noisy environment in-house. However, our value of our component is to ensure that it can be reach the good power level with the good accuracy transmits signal in the wireless products. For instance, for Wi-Fi 6E, this shows that we can either for different bandwidths, it can reach around 20 to 21 dBms, these power levels in this new 6 GHz bands. And also, so in the most of the scenario are using the multi-user MIMO situation. So when they're using multi-MIMO, which means that they might have a lot of interference in the ears. So under the multi-user MIMO situation, we have to get a better linearity for the IF components. In the chart, we shows that even in a different packet length, we can still keep the same power level under very good linearity criteria, like a minus 43 dB EVN criteria. So even for the 4 millisecond packet length, when they transmit the high data rates, RichWave's product can be sustained the same level. And also not just for the transmit but also receive. Receive is more related with the sensitivity and coverage. When the receive is more related with the listening coverage. For instance, the client have not like AP have these high power levels as the IP router. However, the client need to get connected with AP, so they has to be get a good listening, good sensitivity to link with the AP. So RichWave can provide the very good noise figures products. For instance, the 5 GHz we can reach around 1.5 dB, and noise for 2.4 it can reach around 1.4 dB for noise speaker. And even for the 5 to 7 2 GHz band, our ANA only can reach even less than 2 dB. So in overall, we believe our RichWave's receive capability will be the leading performance worldwide. Also, not just for the receive, but sometimes we need the very far unit to the AP router, so the range need to use the high power to reach this distance. The chart shows that our foreign module can reach 23 dBms on the MCS 11 criteria, and also reach 28 dBm for the low rate. And another benefit for using our IF component is how is related with the battery life. And with our linear foreign modules, they can reach around 20 dBm output. They can around 170 milliamp. However, if you're looking for non-linear FEM, you can see they can be even lower if it is lower current consumption needed. Same as for 5 GHz foreign module. For the linear foreign modules, 20 dBm output can reach around 250 milliamps. However, when you're looking up to the more efficiency foreign modules, our non-linear foreign module can be even lower to 170 milliamp under 20 MHz output. So this linear can bring very high efficiency to overall devices. Those linear fans had to be attached with the SoC together to bring up the whole system together. Another feature that RichWave products can provide the multi-mode, especially for mobile phone client applications. They usually will provide 3 modes, can be more flexible to mobile phone and client applications usage. For instance, there will be separate high gain mode. They can reach around 18.5 dB amps on the minus 40 dB EVMs. However, there's a mid gain and low gain. For instance, like in the low gain modes, even though there's a small power level, however, this means that when the client is very close to the APRs, you can use very wide bandwidth with very good linearities, but less powers. Then also it can save much more currents at low power modes. So this very flexible gain mode allow the client to be used more efficiency on the applications. And the last, our Wi-Fi 6E products for application have RTC 6903 and RTC 6904. They both can be support this Wi-Fi 6E new bands. So this is a very quick update our Wi-Fi and the rest will be the very quick update about our values on the 5G new radio products. 5G is different with the Wi-Fi. Different modulation, different bandwidth. However, we provide the 5 component for 5G as well. One of the key features that will provide component is the switches. Switches can be used on selection channels, selection receive, and selection diversity. This can be used on the transmit side or receive side. And also, all the advantage of switches that we all can be support this new SRS feature with very fast switching times, and also not just for the 5 GHz. Our switch can actually extend to other applications, for instance like ultra wideband. It shows that it can even support up to 8 GHz bands for ultra wideband applications as well. These two switches shows that by different power handling levels, they all can be supported not just for the 5 GHz sub 6 GHz application, but also ultra wideband applications usage. the above is the very fast switching time feature. You can support the SRC feature to get a good channel estimation needed in a 5 GHz requirements. And also, RichWave are in developing the switches with different needed. One is the antenna tuning switch. Antenna tuning switches is allowed the same antenna can be more efficient on the usage to get more freedom to get the correct frequency or correct patterns. And also the antenna swapping switches. And for receiver, we not just provide switches, but also the receive FEM's file modules. For instance, for the new Band 77 families, all the combination of the receive for the 5 GHz sub-6 GHz bands. So overall, we provide the best switches and best combination of receive file module and also different usage switches in antennas, like antenna tuning switches, but also antenna swapping switches. So, RichWave will be not just only attached with the Wi-Fi, but also leveraging to the multiple technology in the future. That's our very quick update today. Thanks.
尽量掌握一下时间，在2点55分的时候回到座位上来。好，谢谢大家。
It's an honor and a privilege to be invited to participate in the symposium. RichWave Technology is a Taiwanese RFIC design house. We envision a world where everyone and everything is connected together. Wireless connectivity is what makes it possible. Therefore, we're dedicated to developing the technology that helps us better communicate with one another. Our product lines include Wi-Fi, cellular, 4G, 5G, IoT, passive, automotive, and sensor. The technology we use are gallium arsenide, silicon germanium, silicon non-insulator, CMOS, bulk and surface acoustic wave. The topic for today will be on the latest developments in the Wi-Fi world and what we are doing to help moving the industry forward. For nearly 2 decades, Wi-Fi users have had to cope with a very cumbersome technical naming conventions to determine if their devices support the latest Wi-Fi versions. In 2018, the Wi-Fi Alliance announced a new naming system. Wi-Fi generations are being numbered at the most important level of improvement. 802.11n is now referred to as Wi-Fi 4, and 802.11ac is now called Wi-Fi 5, and 802.11ax is Wi-Fi 6. Using a simple digital number to represent a different generation of Wi-Fi makes it easier for everyone to understand and memorize the evolution of the Wi-Fi standards. In 2020, the United States Communication Commission opened a 6 GHz unlicensed 1.2 GHz spectrum from 5.925 GHz to 7.125 GHz to the regulators that use Wi-Fi 6E, so that the Wi-Fi frequency band can be further expanded to cover 2.4 to 2.5 GHz, 5.125 to 5.895 GHz, and 5.925 to 7.125 GHz. It will further enable the higher speed related application of the wireless network to be more effective and common. The next stage of Wi-Fi 7 uses MCS13, 4000 QAM, 320 MHz modulation waveform in the 16 by 16 MIMO architecture. The data throughput increased to 30 gigabits per second, providing customers with better experience in high-speed applications such as the AR, VR, or low-latency remote surgery. Put simply, Wi-Fi 7 can be considered as what you would get if you apply the requirement of the 5G technology to a wireless LAN. While Wi-Fi 6E spectrum and Wi-Fi 7 specifications are being formulated, RichWave has already begun the research and development of Wi-Fi 6E and Wi-Fi 7 RF front-end module. Meanwhile, we cooperate with major Wi-Fi chipset platforms on the next generation of interface specifications, and we work together to jointly develop the reference design of Wi-Fi 6E and Wi-Fi 7 platform. RichWave offers the complete Wi-Fi 6E front-end module product portfolio to cover different platforms. For Broadcom platforms, we offer RTC 66903 with package size of 3 by 3 mm square. RTC 66903 is a middle high power RF front-end module that supports 20 dBm for MCS11 modulation scheme with bandwidth of 160 MHz. It is in sampling stage and is being validated on customer system board. RTC 66904 is a high-power fan with package size of 3 by 5 mm square. It can support over 25 dBm mask power and has also reached sampling stage this year. For Qualcomm platform, we offer RTC 66914 with coupler inside. Its package size is 3 by 5 mm square. It supports 20 dBm in MCS11 modulation scheme with 160 MHz wide channel, and its low rate mask power is over 25 dBm. We have also developed nonlinear PAs in the 5 GHz and 6 GHz frequency band, which can support DPD function of main SoC chip and greatly reduce the power consumption of the system. Our technological capability has also reached Wi-Fi 7. Our Wi-Fi 7 product lineup are RTC 66226 for 2 GHz band, RTC 66506 for 5 GHz band, and RTC 66903 dedicated to the 6 GHz band. They support 20 dBm for MCS13 modulation scheme with 320 MHz wide channel. All have been internally tested with success. Wi-Fi has a great effect on how we work, play, and live. By increasing the amount of spectrum that Wi-Fi can share, we can continue to expand to different applications and increase the speed and capacity of our connected lifestyle. With the evolving Wi-Fi standards, we will continue to develop products that expand to support even higher throughput and low latency. We looked at its future capability to enable a hyper-connected world, and we are very excited for its infinite possibilities. Thank you. For the second half of the symposium, we're very honored to be able to invite Dr. Lee from the National Taiwan University. His specialty focuses on millimeter wave and terahertz radar sensor techniques. Today, he will be sharing with us the results of his study. Let's give him applause and welcome him. Hello, everyone. My name is Chongxing Li from National Taiwan University. I'm honored to be invited here to share with you the results of our team study focusing on millimeter wave and terahertz radar sensor techniques. If you're interested, you can contact me personally afterwards. This is the outline for today's topic. First, I will introduce you to microwave, millimeter wave, and terahertz applications and their challenges. Next, I'll be sharing with you terahertz imaging radar and communication systems. On this page, I want to show you the wireless technology involvement from 1995 to 2030. Wireless technology enables voice and data and entertainment virtually everywhere. And the rate of its improvement has been faster and faster. And now we reach the third wave of revolutions in wireless communications. You probably heard of AR, VR, SR, or remote surgery, or the most popular metaverse are also examples of the third wave revolution. For 6G technology requirements, one of the most important factors is extremely high data rate and capacity. Its peak data rate is expected to reach over 100 gigabits by exploiting new spectrum bands. So everyone expects that 6G wireless network will implement terahertz in order to cover all the frequency bands. But 6th generation wireless network needs such high frequencies. That's why we'll need a lot of base stations. And also we'll need smart reflectors to reflect the signals in order to reach the designated destination that we wanted to reach, including to car, the walls, the building, everywhere will be able to implement the small base station in order to extend the signal. For all the applications, not only common communication, it can extend further to data center or intra-device and a lot of other areas. 6G communication is very popular nowadays in the US. You probably heard of Constantius. A lot of the major universities in the United States have invested a lot into the 6G investment. So this is very important nowadays. And in Taiwan, in recent years, we are rigorously promoting 6G as well. Millimeter wave can also be applied to sensor usage. This is an example of car radar. It operates at 24 and 77 gigahertz. And it can detect people or car and everything. And for Google solely, it utilizes 60 gigahertz band. As you can see, radar for higher frequency band has been commercialized. When you are driving a car and there is fog on the window, and you can use the sensor to detect the road to see clearly. And all wireless communication are moving farther and farther into higher frequencies. And also they are being commercialized. They can reach up to 300 gigahertz. And the application is extremely wide, including material detection, weapon detection, data communication, terahertz spectroscopy, and for medical use as well, to detect all kinds of cancer. As for the packaging, semiconductor packaging, it can detect whether the packaging has been complete or not. As for throughput, one of the implications of terahertz is throughput. This is a very popular company that it has a lot of products for through vision to detect whether the passengers carry weapons. You might wonder, will anyone ever use such higher frequency product? But yes, Los Angeles Metro has selected this company to implement its terahertz technology. So this is the industry with a lot of potential where it can be applied to every airport and every store. So we can see the frequency is moving higher and higher constantly. And more bandwidth will be available at higher carrier frequency. Everyone is moving to higher frequencies. The other benefit is that smaller antenna and shorter spacing between antennas. And enables the system to be made in the size of smaller size. Now, the 320 megahertz has been identified, and everyone is moving toward its goal to bring out a product that comply to this. But it's also very challenging. I'll let you know what are difficulties for terahertz. The first challenge is because the terahertz prefer to work at higher carrier frequency bands. With higher frequency, but your SNR need to be the same. No matter it's with 3 giga or 300 giga, you need to have the relative SNR complying to different frequencies. But then, in the meantime, bit error rate will be caused. With higher SNR, the bit error rate will decrease. And also, the moisture in the air will affect the precision of the transmission. When it's raining or it's foggy, it's more humid, and it will cause more attenuations. This page is on N-element phase array. You can see the formula. Terahertz is very hard to develop because it only allowed half lambda between two transmitters. It's very difficult to design a product that fits into these little spacings. And the area, as you can see below, is very small, so it makes it even harder to develop products. In order to do that, you need to use AIP. All these are very difficult issues that everyone needs to tackle with. Another difficulty is that you have so many arrays, and how do you make sure that each one of the arrays will be matched? If you use CMOS, it's not fast enough. So, for example, TSMC use it for CMOS. Other problem is the output power. So we use indium phosphide PA in order to tackle all these problems. We need to integrate it into CMOS. Another thing is power dissipation. One transceiver will cost 1.5 watts. If you need 250 arrays, you create a huge amount of power that needs to be dissipated. These are the key factors of the systems. You need phase array, IMP technology, CMOS technology, power efficiency, packaging AIP, heat dissipation. You need to develop the relative AIP packaging technology in order to develop the products. In our lab, we focus on tile-based terahertz heterogeneously integrated phase array systems. Next, I'll introduce you to imaging radar and communication system. In order to incorporate different systems, SoC is impossible. You need to use system on package. In your systems, a different module will use different technology, different process will be most suitable. And then you integrate all of them on one system board in order to successfully develop the products. This is the only way possible. And in our way, we have done a lot of research and study into these integrations. This is the systems that we have developed to incorporate different technology and systems onto one system board. The signals can be passed with extremely small attenuation and loss. Our lab, we developed 250 arrays on the systems in the 340 gigahertz TX. These are some examples of the packaging technologies for 340 gigahertz cellular, 50 gigahertz. Our lab has completely developed all the components for this technology. And now, after development, we're moving toward developing the system. We're using our own chip that we designed by ourselves. On the right bottom side is the chip that we have developed. You can see the beautiful image with the very good results. The resolution can reach 1.4 millimeter. What is this system we have developed exactly? This is a terahertz Fncw radar for security application. We make a radar chip for some LiDAR technology to detect whether the passengers are carrying weapons. Before doing it, you need to do systems analysis. I'll move very quickly in this page. You need to do cross-range resolution to enhance the frequency. This is the size of the resolution range, and this is very good range. This is the Fncw radar link budget analysis. As you can see the equations, the TX to RX isolations, for them not to interfere with one another. Let me quickly summarize the comparisons of the spec. When it operates at 323 gigahertz and the relative size, you can compare microwave and millimeter wave, the range, the cross-range resolution, the spot, the range array. This is the structures that we have developed in our lab to extend the frequency to over 300 gigahertz. This is the new technology that we need in order to develop product that will operate in higher frequency. We develop constant loss control. It is using embedded network to help the transistor to operate at the most ideal level. And sometimes we need to develop our own chip and the own transistors. This is the photo layout you can see. This is the result of our design. Of radar performance summary, you can compare the spec and the design and each parameters. This is a list of our team at Untitled and the topic of our subject that we are working on. It's called 240 gigahertz millimeter wave wireless transceiver. Now, I'll introduce you to the difficulty and challenges of this technology. In the first 2 years, we want to use home antenna probe to home loss equals 6 dB. The range is only 30 centimeters. And now we are replacing the home antenna with our own antenna. And the target is 80 gigabit per second. This is for your reference only. The most important issue is, can this thing be applied to 100-meter range? Is it feasible? The answer is yes, but under the premise that we need phase array technology. And then we need to have 512 phase array in order to achieve this level. If you want to reach 300 meters, you definitely need IMPPA. Now we are not doing it. Nobody is doing it. But it's possible in the future that we will begin to do it. These are the 3 blocks. In order to overcome this challenge, we try all we can to develop tile-based phase array. And this technology makes it easy for us to come up with 512 phase array. We're constantly enhancing our integration capabilities. How do we use additional diagnostic for the phase array collaborations? This is a very interesting topic. I mentioned that we need a lot of new IC designs for the phase array. What's special about this technology? is that they have applied provisional patent applications. We can develop a transceiver, use one transistor to integrate all in one. This is the only way possible. And we have applied for patent. This phase array can operate at our designated spec. With 4 channels, they can come out with the results that we want. If you're interested, you can talk to me in private because I have reached my time limits. This is my conclusion for today. Our lab has developed a lot of interesting and advanced chip, IC, and phase array systems. We've discussed some of our new structures to integrate everything under higher frequency range. This is a very quick introduction. If you have any further questions, contact me in private. Thank you. Thank you, Dr. Lee, for your fascinating speech that inspired all of us. Next, I'll be in charge to discuss passive components with you. Now I'm feeling a lot of pressure. To begin with, we're a wireless communication company. I've been always asking some of my friends, what is communication? Think about it. Everyone is using smartphone right now, whether you are using Wi-Fi or LTE. Before this Wi-Fi LTE technology, how do you serve the internet? Can you remember? If you can answer this question, it means that you're over 40 years old. To communicate is to fight against noise. And what are the causes of noises? They are the different frequency, signal interference, and different channel bandwidth. They can all be the cause of noises. So how exactly do we communicate? If we use the same protocol, then we can use the same protocol to exchange message. All messages have to operate under the same protocol. The same protocol is the second important factors of communication. From receiving to sending, we need to continue to decode. But this is very complicated. To put it simply, what is communication? Communication is you can hear what I say, and I could hear what you say. And also, you could know what I say, and I could know what you say. This is at the core of telecommunications, to reach the same protocols and communicate. And this is what we are doing at RichWave. We are designing RF components to help everyone to better communicate with one another. And the third factor concerning communications is noise. All of us are fighting against noise every day. How do we enhance the linearities to successfully decode the signals? Somebody once said, if the transmission medium is noise-free, then all of us will be out of our job. What is a noisy environment? the air, the wall, the ceilings, the ground, all of them will cause noise for communications. We are trying to solve all these problems concerning noise all around us in our area. This is the distribution of the most well-known frequency band. As you can see, there are licensed and unlicensed bands in different frequency bands. Wi-Fi being operated in the 2.4 GHz and 5.0 GHz bands belongs to the unlicensed band. Everyone can use the unlicensed band, so a lot of interference will be caused. As for 3G, 4G, and 5G, they belong to the licensed band category. The market generates a lot of profit for the government and network operators. Network operators in Taiwan, China, or other countries in the world have been paying the government big sum of money to acquire these bands. This shows how valuable these bands are. Therefore, it is of utmost importance to offer signals of the highest quality for users using the licensed band to have the best experience possible. We hope to offer high integration products to integrate all the bands in one-stop shopping for our customers. We are professional RFID designers, and we are also good at filter designing. Combine the filter into our front-end module product to come up with a newer kind of product to fulfill our customers' needs. In the past, Wi-Fi used 2.4 GHz and 5 GHz, and now we have newer frequency bands such as sub-6 or millimeter wave. All of these frequency bands, they cannot possibly share the same frequencies. So we need filters. In order to select what frequency we want and filter out what frequencies we don't want. You can see millimeter wave and also extending to radar wave. A lot of wireless signal exists in this world. We need to select what signals we want and what signals we don't want. And filters plays an important role in this area. What is a filter? And what is it used for? The air we breathe is filled with wireless signals, but only one frequency will be used by one device. That's why we need filter. It is used to capture wanted signal for the device and also filter out unwanted signals. This is the most important spirit of the filter. You can see the table on the right button for the definition of frequency. There are 4 categories of filters. Discrete filter, LTCC, SAW, and BAW filter. As for LTCC, is achieved by using porcelain, silver, and copper. If you want filter of higher quality, you would choose silicon, SAW, and BAW. Operating bands for SAW can reach 3.5 GHz. It is applied widely on LTE and low bands on smartphones. In the future, both filters can be applied to higher frequency, such as 5 GHz and 60 GHz. Operating frequencies can then be reached to 110 GHz. In the future, these BAW and SAW filters will coexist on the systems in the future. And for us, we'll focus on LTCC, SAW, and BOW filter. LTCC is the black line, and you can see in the graph below. SAW is the blue line, and BOW is the red line. LTCC declines slowly. It cannot cover deep into the signal, but the advantage is that its bandwidth is very wide. It can reach 100 gigahertz. SAW is between those two. Where exactly is filter being placed? The purpose of filter is to filter out unwanted signals and to receive and send wanted signal. Therefore, it is placed at where the diplexer is of the transmit and receive channel. And filter plays a key role in the Wi-Fi systems. It can put outside or incorporate inside. These are the key specifications for filters. They are center frequency, max loss, and ripple, passband bandwidth, and attenuation. These factors are defined to meet the customer's need. We're going to implement SAW into our mobile product. A lot of filters will be needed on smartphones. We hope to incorporate filter and our LNA switch and PA into our products. This is our product line for LTE and 5G. And these are different bands for different regions. Some are available parts, some are developing, and some we're still planning. But the end result is that we will bring out a complete product line for our filter, for our customers. The technology we use will be SAW, BOW, LTCC. A lot of people use SAW filters on their smartphone nowadays, but it has its limitations concerning frequency. So we are keen to bring out BOW filter in order to overcome this challenge. You can see the passbands, the attenuation, and the key features of our RTC 46S2R UHA product, our SAW filter, in its performance benchmarks. Single box include LTE and Wi-Fi. As the frequency bands are close, to prevent each channel from interfering with one another, we need to use the right filter for all related frequency bands. This is the actual results of our Wi-Fi BOW filter. You can see the frequency range of in-band and out-band to be able to better switch between the in-band and out-band. And this is what I want to share with you, our filter product roadmap for the next 3 years. We're going to develop product for different applications, Wi-Fi, GPS, and mobile. We hope that we will not only have Wi-Fi, we'll also have passive device to be a fully complementary company. Thank you. It's me again. Next, I'll talk to you about Internet of Things. On the right graph, probably most of you have seen it. According to market analysis, IoT market within the next 3 years, the total device for this market will extend beyond 2.5 billion. But the whole human population is only 0.7 billion. Why is IoT expanding at a rate faster than human expansion? Because in each household has a lot of different devices that is connected to the internet, such as your air conditioner, your refrigerator, your light. In the future, it's a future of Internet of Things, where everything in your home will be connected together wirelessly. Wireless will become very important for IoT in the future. What is the benefit of connected all the devices to the internet? Nowadays, people are talking about big data and what is it used for? What is the advantage? This is the pictures that we capture from our everyday life. When we are waiting for a bus at a bus stop, you can see the bus you want to take when it will reach the stop. This is part of IoT. Through the LTE signals sending to the bus stations, it can gauge the time and tell you exactly when the bus will reach the stop. When you're about to park your car in the parking lot, you wish to know where you can find the parking space. This is also one of the other applications. You can use sensor. Before you get into your car, you send a signal through the sensor and assistant 10 minutes before you reach home. And also, you can send signals and tell the air conditioner to open because you are going to reach home. So it can open before you go home. And when you go home, you can enjoy the most ideal atmosphere and the temperature. All these things will be made possible through wireless communications. Concerning smart homes, you can imagine the plug. You simply plug a plug now. But if you use wireless and sensor, IoT and sensor can be highly integrated together to create a whole complete ecosystem. If you plug in the plug, it can analyze how much power you are consuming for this device, such as Amazon have Alaska in China. They can do configuration of all the power consumptions of your in-house devices. The analysis how much power the household and each devices are using, and tell you the result of this analysis. And you can determine if you want to change and use a new device because it's consuming too much power. Also, if your refrigerator is connected to the internet, your refrigerator will tell you whether you're running out of milk, and it also will tell you where you can buy the milk you want, where you can find everything at the proximity of where you live. In the future, automotives will implement sensor technology too. For example, the self-driving car. Some of us will question the reliability of self-driving car because of our past education. If a car can implement sensor technology, then the data can be sent to the info system, and the info system will collect the data from the environment and do analysis and determine if you are being safe. We have been contacting our customers for automotive products recently. When designing product for IoT, you need to take into consideration the power consumption. Because you don't want your house to increase the power consumption once you implement a lot of the IoT device into your home. We want to maintain the power consumptions under one's reasonable level. And we need to also take into consideration the data rate. It is high throughput and high signal resolution, and it's very likely that it will implement Wi-Fi. If it's low data rate and it is accessed by request, then it will be more likely that it will implement LoRa and BIoT. Nowadays, everywhere in the world, the biggest application for IoT is smartphones, and it is also the trend for the future. For Wi-Fi and Bluetooth to be the two major technology for IoT. Because smartphone didn't select Zigbee, so Zigbee is not as popular as Wi-Fi. When we're devising IoT device, if the device uses AC power adapter or if it's using battery base, the consideration is different. If the device uses battery, then power consumption will become even more important for the device because it can easily run out of power. In the most ideal scenario is we place a battery in the device and it can last 3 to 5 years. For IoT, we wish to enhance the user's life with our IoT products. This is our product for Bluetooth and Zigbee for IoT implications. You can see the structure for Bluetooth fans, super low standby currents and super low power consumptions, and very small size package. In China or in Europe, a lot of customers are using our fan for Bluetooth and Zigbee. Another characteristic of IoT device is that it is not as complicated as Wi-Fi or Bluetooth. So for IoT, switch plays an even more important role. One channel or dual channel, control one signal or two signals, will design the most suitable solutions according to different system IOC. We have some advantage over our competitors when comparing the features of our IoT products. At last, let me introduce you to our automotive product portfolio. Besides from considering power consumption, we want to be able to incorporate it into automotives. We have passed ACQ 100 certifications. In the future, in smartphones, we'll do higher integrations. We in compliance with AEQ 100. three factors of IoT: one, wireless; two, sensor; three, big data. We want to integrate these three to come up with a good IoT product. RichWave want to walk with you on this path to embrace a smarter life in the future. Hello everyone, welcome to Technology Symposium. I'll talk to you about radar sensor in homes, consumer, industrial, and car. For sensor, we put them into three areas: home, industrial, and car. For smart lighting and smart home products, we have already begun our shipments from last year. For smart homes, including smart speaker and presence detection, I will talk to you about it. I want to focus on smart security. A lot of us use CCTV, but now, because wireless doorbell is popular, the main difference is that using radar sensor to sense when someone approach my home, and there will be a video sent to your smartphones. And so the guests don't have to press the doorbell and you'll know someone is there. For industrial, for autopilot will be used in agriculture or industrials to keep the autopilot at a certain level to prevent them from crashing into each other. And also, we have the industrial, transport, and robotic to prevent collisions. And for level detections, I'll talk to you about it later. For consumer versus notebook, we are implementing our sensor into notebook for presence detection. And for vital sign, to detect the vital signs such as breathing or heartbeat. Automotive use sensor, but people think it's used only in car. There are two types. The first is outside of the car. The first one is not smart trunk opener. And we have the blind spot detection. We have been focusing on this area for years. And also we'll do child presence. In these few years, it's quite popular for child presence. NCAP requires that every year 40 or 50 child will be found in the car accidentally and lose their life. So NCAP requires in 2025 that it will set up the law that every car will be equipped with a child presence detection sensor. There's one car using child presence detections. Other in-car application is driver monitoring to detect the driver's breathing and heart rates. That's the GET radar sensor market. Expect that consumer home appliance will grow 56% from 2020 to 2025. We focus more on consumer and home appliance. We expect a 50% growth. As for in-cabin sensing, the market expects a 72% growth rate from 2020 to 2025. is growing very quickly. DMS and OMS. What is DMS? Driver monitoring systems to detect drivers' vital signs, and OMS is to detect infants on the back seats. It's vital signs. I'm very happy to share with you product of RichWave sensor. Put them into 3 applications: smart appliance, car security, and smart lighting. Our FOV have wider angle, and it is not affected by temperature. And starting from smart lighting, we move to different applications, such as car security. And how we do it is that we connect sensor to OBD. So when your car moves away, the OBD still provides power, and it will tell you whether if someone breaks into your car or someone approach your car that might cause a danger. It will send the message to your smartphones to inform you of any possible danger. And lastly, the home appliance. We have reached mass production phase for our home appliance sensor products. Within the certain area, they can detect if anyone exists. If it detects no one is in the room, and the air will slow down and even close, and you can even tell how far away the person is from the air conditioners to determine how strong the airflow should be. For IoT and sensor, the product number will increase a lot in the future. We have more projects going on with our partners. The first one is for level detections taken in our lab. You can see the tank in our lab. In the US, a lot of the tanks are used for industrial use. So it's impossible to have someone there to detect the human level for the industrial tank. That is why we need to implement sensors in the tank to automatically detect the liquid level of the tank. Therefore, you don't need to open the jar of the tank, and you will know how much water is in the tank. And this can be applied to farmhouse. And for notebook, we're also focusing on notebook to pair up with our sensor hub. The first is presence detection. When someone approach the smartphones and open the notebook, it automatically enables the facial recognition and start working, turns on the monitor. And when the person leaves the notebook or moving farther away from it, the sensor will detect that the user is going away and automatically turn off the screen to protect your privacy. And also it can detect the user's vital signs, such as heart rate and breathing. Some gamers, when they play game with notebook, sometimes their heartbeat will raise up to a dangerous level, so the sensor can help detect that. On this picture, on the left, you can see the presence detections. You can put it on smart speaker or temperature controller, such as Google Nest Hub, to record how well you sleep. You can put it in your toilet. And the toilet will automatically opened when you approach. You don't need to use your hands anymore. PIR cannot differentiate if you're moving from right to left, but radar can differentiate that. Also, we have standalone vital sign detection. When FCC issue approval for NAS Amazon to use sleep monitor, I'm going to introduce you to our RichWave microwave sensor roadmap from 2020 to 2022. 2 by 2.2 is the smallest size. We can do motion detection. This year, we began to ship UWB radar sensor with higher detection range, with DSP, with algorithm. Our goal for next year is for 60 gigahertz millimeter wave sensor, AIP, with antenna in packaging, and also global UWB radar sensor to support 1T, 2R, and also capable of AOA to detect two-dimension tracking. And now, later, I will give you a demo on stage to show you the two-dimension tracking. I have to face you. I have to look at you. So you can see. This is me. The green spot represents me, where I am, my location. Now, we used to offer only one dimension, but now we offer two-dimension detection. We use single chip, but we can offer 1T, 2R antenna with our algorithm. For certain market, it will be very interested. Because in the past, sensor only tell you how far you are. But now, it can tell you more, like where you are at the x-axis and y-axis. The exact locations, more specific. This is my live demo today. If you have any question concerning sensor, you can ask me anytime. Thank you. Hello, everyone. Good afternoon. I'm T.S. Liu. It's an honor today. I'll talk to you about our quality and production. In today's competitive environment, we've learned how important quality control is for the success of the company. RichWave quality assurance is based on ISO 9001 QC 080,000 certification. It extends into product development and qualification of higher specifications and quality for industrial and automotive use. We implement our quality assurance into our product design, delivery, reliability guarantee, and after-sales service to construct a complete quality control management system. By doing so, we hope to reach our end goal, which is to provide maximum satisfaction to our customers. Following the spirit of PDCA, we applied of quality management to our in-house design products, product qualification, mass production, and customer acknowledgement. We monitor product reliability, hold change list review meeting, conduct professional failure analysis, and customer service through supply chain management. Of course, to reduce product development time, optimize product process, and monitor product quality are also core of our quality management. We have enhanced PLM system to manage product design flow. We have switched to SAP system to speed up our production and delivery. We have also implemented B2B knowledge database to enhance file sharing with customers and supply chain. To systemize our management flow can enhance product quality and production efficiency. It will help us fulfill our promise to our customers. This is our process technology roadmap. For active transmitter, we use gallium arsenide and silicon germanium for PA design in 2020. As for next year, we're going to use gallium nitride for PA design. For active receiver, the percentage of CMOS SOI will increase in 2022. For passive device, we began ball production development in 2021 other than SAW filter. And in 2022, we will incorporate substrate-based IPD. For packaging, we will implement AIP, antenna in packaging, and AOP, antenna on packaging in 2022. In the RF industry, it can be quite challenging trying to enhance mass production, testing ability, and production quality. As for this part, we have found the solutions one by one through our partner support. In the meanwhile, we will keep our cost competitive. In order to be more internationalized, we have begun to implement testing platform of big international brands such as NI and PAX. And this is our ESG actions concerning supply chain management. Because we care about environment and we care about ESG, and we have dedicated our each different departments to do ESG, including quality and production, and to conduct supply chain management. We have conducted a comprehensive audit of 23 major suppliers, focusing on 3 major supply chains, including wafer, packaging, testing, with an audit coverage of 100%. And we found that the suppliers who have completed our audit are facing the challenges of embracing positively and aggressively. Thank you. Comparing this year and last year, there's a big difference. Can you see now? The schedule management is perfect. The timing is perfect. We only missed 5 minutes. All the speakers, all the guests cooperate perfectly. Thank you so much. Today I give you conclusions. To give a conclusions, I have 2 things to share with you. In fact, all the technology, what is technology for? Technology is to enhance our life, to make our life better. Our major business is Wi-Fi, a wireless environment everyone have enjoyed for years. Can you remember when in the old time you used dial-in modems? I remember when I was only 12 or 13 years old, I had my first modem. I think the gee sound, and I was excited because when you go onto the internet, you have infinite information there. From 2019, because of the U.S. and China trade wars. And it has caused a strong increase in demand for RichWave. And now we suddenly found ourselves in a situation that a lot of customers are needing more and more of our products. And we want to give special thanks to our supply chain partners for supporting us with the capacity we need and helping us. In order to catch the demand, you can see it through our revenue, what we had done and achieved. When we reach the first quarter of this year, we're feeling a different atmosphere. The atmosphere came from supply chain shortage, IC chip shortage. The different priority of product shipment from the IC chip has caused a headwind for RichWave. Now I want to share you one example. In China, in 2019, our retail market share was only 10% or below in 2019 in China. But in 2020, our market share in the Chinese retail market has increased a lot. But our market share has exceeded 50% in the China market. This is a very solid growth. You might not be able to see it through revenue, but still I want to thank all of you for supporting us through the difficult times.
这个
On this page, this is the China Gateway Tender Market. In 2021, this is how the Chinese tender market looked like. In 2021 and 2022, the total amount of equipment has increased 52%. You can see the single-band Wi-Fi GPON has decreased 82% year-over-year, but dual-band Wi-Fi 6 GPON increased 595%, and dual-band Wi-Fi 6 GPON has increased 167%. What I'm trying to say from this image for investors, for supply chain, or for all customers, the demands for our future market needs is very, very strong. This image doesn't include AP router. It only includes PON and 10G PON. I hope everyone, our customer, supplier, let's embrace the challenge and conquer it and succeed for the future together. Now let's do Q&A. Does anyone want to ask a question?
有吗？没有的话，就是给
If there's no question here, and that's open for QA, online. Does anyone want to ask a questions online? You can leave us a message. We have one question about new Wi-Fi 7. I'll first explain. As far as I know, the concurrent now is still in the same carrier band to do upload and download. But for a new Wi-Fi 7, the MU MIMO will be different. It's 2.5 gigahertz will be fine for uplink only, and 5 gigahertz for downlink only. You'll be limited to 6 gigahertz to do some programmable. It can enhance performance. Then another question is about 5 gigahertz and 6 gigahertz. Will they use filter? I think, yeah, on smartphone, yes, smartphone will use it. And for Wi-Fi 6E smartphone will also use filter. For Wi-Fi application, we're going to bring out a more complete product portfolio and face any challenges facing us bravely. The last chance for questions. I think, yeah, digital pre-distortion PA we have been developing. In 2019, we began to sell nonlinear PA, and the shipments reached millions of pieces. The coverage bands is faster and faster and become more difficult and difficult to design. We are going to move with our own design, in-house design team to move forward for more and newer version technology. Wi-Fi is for dual bands. Looking at the whole is for Wi-Fi 7. The purpose of Wi-Fi 7 is to help the users' number increase. In the future, each household, the number of total device will skyrocket. Now I think of one thing. When we talk about sensor, the one thing I want to add. What is the first thing you do when you go home? What do you do when you go into the door of your house? You open the light, right? Our smart sensor in the future will deliver the convenience to you that you no longer need to turn on the switch and open the light. Wherever you go, the light will follow you. The light will open wherever you go. And it can also distinguish between day and night. And it will make everyone's life so much easier and more convenient. Do we have any questions? The last one. No question? Okay. Thank you so much. See you next year. Goodbye.